Vera Rubin sent this strange transmission, and it is a warning. Something is moving through our solar system, and it got here before anyone on Earth was watching. Not a signal, not a message. A photograph taken by a machine containing an object that shouldn't have been possible to catch. And once scientists went looking, they realized this wasn't the only thing hiding in the data. You won't believe what else they found. Here's what we thought we knew. The universe is big, telescopes are slow, and discovering something new in space takes years of patient waiting. By the end of this video, you'll understand why that assumption just collapsed, and why a single observatory, scanning the sky every few nights, is now generating more raw discovery than the rest of astronomical history combined. And wait, there is more. This is the Vera C. Rubin Observatory, sitting at over 2,600 meters on Cerro Pachón in Chile, jointly run by the U.S. National Science Foundation and the Department of Energy. On June 23, 2025, Rubin released its first look images. In that single batch, it had already captured roughly 10 million galaxies, and scientists were clear that this was a fraction of what's coming. Over its planned 10-year survey, this telescope is expected to catalog around 20 billion galaxies. To put that in human terms, imagine being handed every book ever printed, then being told it's the introduction to a much longer series. Rubin isn't photographing the sky. It's building a time-lapse of the entire universe, one full scan every few nights, using the largest digital camera ever built. And this camera doesn't sit still. Every few nights it sweeps across the entire visible southern sky, then does it again and again, for 10 straight years, comparing each new image against everything it saw before, hunting for anything that moved, brightened, dimmed, or simply wasn't there last time. But that is not everything. There is more. Almost immediately, the flood of data started breaking things. Every few nights, as Rubin rescans the southern sky, its software flags anything that changed: a star that flickered, an asteroid that moved, a galaxy that flared. That number sits at close to 7 million alerts a night. Every single night. It wasn't even close to the strangest thing Rubin found in its first weeks. Buried in that flood was a single asteroid. Roughly the size of a skyscraper, about 710 meters across, wider than the Empire State Building is tall. Astronomers designated it 2025 MN45, and when they measured how fast it was spinning, the number didn't make sense. Under 2 minutes. This half-a-kilometer boulder completes a full rotation in about 113 seconds. For an object this size, that shouldn't be possible. Researchers who studied it said plainly that whatever this rock is made of, it needs a cohesive strength close to that of solid stone just to survive its own spin. This one didn't fly apart. That means 2025 MN45 isn't loose rubble at all. It's holding together with a structural strength closer to solid rock. And it wasn't alone. In that same first batch of data, Rubin flagged more than a dozen other asteroids spinning at speeds that shouldn't hold together, but that's not the strangest part. Rubin wasn't just built to find rocks, it was built to catch the moment stars die. And in one of its earliest passes through cataloged survey data, something didn't die the way it should have. Astronomers have spent decades tracking supernovae, massive stars that end their lives in explosions so bright they briefly outshine their entire galaxy. It's one of the most violent, most visible events in the universe, which is exactly why what happened next was so unsettling. In the Andromeda Galaxy, a massive supergiant star spent nearly a decade quietly fading. No flash, no explosion. It simply dimmed until it vanished from view entirely. It's only the second event of its kind ever documented. One of the astronomers behind the discovery put it bluntly: finding a supernova is easy, because a supernova outshines its entire galaxy for weeks. Finding a star that disappears without one is remarkably difficult, and this one went unnoticed for more than 5 years, buried in mountains of archived data before anyone realized what they were looking at. That's the problem Rubin exists to solve. A survey scanning the whole sky every few nights for a decade straight, specifically built to catch the ones we're still missing, the stars that quietly disappear instead of exploding. That should have settled the question of how rare these events are. But it didn't. If even one star can vanish like this without anyone noticing for years, then somewhere out there, an unknown number of black holes may already exist that were never announced by an explosion. A gap where a star used to be. But that is not everything. Then came the discovery that had nothing to do with a new observation at all, and everything to do with looking backward. In July 2025, a telescope network called ATLAS detected an object moving through our solar system on a trajectory that could only mean one thing. It came from another star system entirely. Only the third interstellar visitor ever confirmed. Astronomers designated it 3I/Atlas. But that's not when Rubin first saw it. Weeks later, researchers went back through Rubin's archived commissioning images, data collected before the observatory had even officially begun its survey, and found the comet sitting there already, captured 10 full days before anyone else on the planet had noticed it existed. On June 21, 2025, while engineers were still running calibration tests, Rubin's camera had already logged the comet, undetected, in nearly 100 separate exposures stretching across the following weeks. Rubin had photographed an object from another star system and simply hadn't been looking yet. Think about what that means. This telescope caught an interstellar traveler by accident, while it was still being calibrated, using data nobody had thought to check. One researcher involved in the analysis put it simply: if the science validation phase had started just a few weeks earlier, Rubin's pipelines could have been fully operational in time to be the observatory that discovered 3I/Atlas first. It came within days of being an entirely different name in the history books. That's not a fluke, the survey will only get once. Scientists now estimate that once Rubin's full 10-year survey is running, it could catch a new interstellar visitor roughly once a year, turning what used to be a once-in-a-generation event into a routine entry on the calendar. So, a spinning fragment of a shattered world. A star that died without a scream. A visitor from another solar system, caught in the corner of a test photograph. 3 separate discoveries. 3 separate fields of astronomy. Asteroids, stellar death, interstellar objects, all surfaced almost by accident, in the first weeks of a machine that hasn't even started its real mission yet. Rubin's real assignment is bigger than any single asteroid or dying star. It's built to track redshift, the way light stretches as galaxies race away from us, across billions of galaxies, and to monitor exploding stars called Type 1a supernovae, across the next 10 years. Both are tools for measuring something we still don't understand: the fate of the universe itself.